Good evening, staff members and faculty. Today, I would like to present to you what our company has currently been researching on artificial blood vessels. As you all know, we have started not too long ago our research and development of artificial blood vessels for those who are affected by diabetes. As you all know, diabetes tends to have many effects. One of the effects that it has on individuals is the effect of kidney damage. And when kidney damage occurs, it then leads to the potential of having blood vessel failure. And this is a dramatic issue with those affected by the disease, as they have a longer than average time required to recover from any sort of injury, including blood vessel failure. Now, we obviously can't just focus on every blood vessel there is in the human body, so we have begun our research and study in the femoral artery. Our standard blood pressure we have taken from an adult male of 25 years of age, and we found that the standard blood vessel pressure was about 0.101 megapascals, with the average wall thickness of 0.7 and the diameter of the blood vessel to be 9.7 millimeters. We have researched into 3 different types of materials: titanium, polyethylene, and silicone. Now, when we look at the specifications of polyethylene, we find that it has elastic modulus of 758 newtons per meter squared, a tensile strength of 2.167 to the 12th power newtons per meter squared, a yield strength of 2.57 newtons per meter squared, and a mass density of approximately 21,450 kilograms per meter cubed. When we compare that to the specifications of silicone, we find that it has an elastic modulus of 1.124 newtons per meter squared, a mass density of 2,330 kilograms per meter cubed, a tensional strength of approximately 1,600,000,000 newtons per meter squared, a yield strength of 120 million newtons per meter squared. And then finally, the specifications of titanium, which we were using, was an elastic modulus of 1.103 to the 11th power newton per meter squared, mass density of 4,480 kilograms per meter cubed, tensional strength of approximately, 861 million newtons per meter squared. And then when we look at the yield strength of titanium, we have 827 millions per newton squared. Now, when we ran our simulations, we found that silicone, polyethylene, and titanium all experienced the same amount of stress, and there was no significant difference in between the materials to justify the use of one over the other. So we came to the conclusion of looking at cost. When we look at the cost of each item, we find that titanium per gram is approximately $6.61. Silicone is about 50 cents per gram, and polyethylene 0.084 cents per gram. And we came to the conclusion that the company should be looking into silicone. And the reason for this is due to its high strength factor, being just as capable to withstand any pressure that from our simulations, which we ran, up to 5 times greater than the standard pressure normally received, and due to its readily accepted nature by the body. Since silicone has already been used on a regular basis, we know that it's resistant to body fluid and it has a lower cost than, say, titanium, not as low as polyethylene, but the reason we chose silicone over it is because its nature of being more accepted by the human body. And that is my presentation. Thank you. Have a great day.